Hi guys, welcome to the session. Myself Dinesh. So today's session is on two important properties of Fourier Transform, and that is time shifting property and frequency shifting property. So these two properties, if you understand carefully, a lot of problems will become very easy. Most of the Fourier Transform problems are based on properties. So how good you can apply these properties to solve the questions will decide how fast you can solve the questions. Okay. Right. So start the session. Okay. So first let me give you the answers for yesterday's homework. So the answer is, this is the question I've given. So x of t signal I've given, time domain signal I've given. So the value of Fourier transform of the signal at f equal to 0. So how do you find it? This is nothing but area of x of t. Just find the area of x of t, and so what is the area? So width is 2 units and height is 6 units, 2 into 6. Plus what is the area of the triangle part? So it is half into base into height. There are like that. There are two right angle triangles here. So it is 2 into half into base is 6 unit, base is 3 units, sorry, base is 1 unit, into height is 2 units, this height is 2 units. So 6 2 is 12 plus 2 is 14 units. That is the answer for the first question. Second question, so if there is any confusion, I told you, just compare it with so this looks like inverse Fourier transform formula, just compare it with that. So inverse Fourier transform formula, x of t is equal to 1 by 2 pi integration from minus infinity to plus infinity x of omega into e power j omega t d omega. This is the formula. So in the next problem, we want it in terms of f. So let's write the formula in terms of f as well. Capital X of omega into e power j2 pi ft into df. So once you write them, then it will become very easy. Okay. So if you compare, so in place of t, what should we put? In place of t, what should we put? We should put pi in place of t. So if you put in place of t pi, we will get this equation looks exactly same as this one. If you put replace t with pi, so which means it is 2 pi times, because there is no 1 by 2 pi here, send this 2 pi onto the other side, it becomes 2 pi into small x of t equal to pi. At t equal to pi means 3.14. At 3.14 we are interested, which is equal to 0. The answer to the second question is 0. Next one, let us see the next one. Let us compare this equation with this. What should we replace t with? So that we get this equation? If you replace t with 1 by 2, that 1 by 2 and 2 gets cancelled, it will become pi f. So if you replace t with 1 by 2, this is equal to, third question is same as x of t equal to half. Okay, so what is x at t equal to half? What is the value? At t equal to 1 it is 6, at t equal to 0 it is 8, at t equal to half it is midpoint of 6 and 8, which is 7 units. So 7 is the answer. I hope you all got the same answers, whoever have solved it. Right. So I'm moving ahead. Any doubts, anyone? You can ask me if there is any doubt. Right. So this is yesterday's homework. So let's move on to today's session. Right. Time shifting property. So these are easy properties. What does the property say? Understand the property? I've written it as a statement. If a signal x of t has a Fourier transform of x of omega, what am I saying there? Observe carefully. X of t, I am saying that it is having a Fourier transform of capital X of omega. then the Fourier transform of x of t minus t naught is, if you know the Fourier transform of this, you can find the Fourier transform of this easily by using time shifting property. With the help of time shifting property, if you know the Fourier transform, if you know a Fourier transform pair, you can find the Fourier transform of any shifted version of this. If you shift it towards right side, left side, by any amount if you shift, you can find the Fourier transform very easily using this property, and that is x of omega into e power j minus j omega t naught. So shifting in one domain or time domain, what will that do in frequency domain? Shifting in time domain results in multiplication with complex sinusoidal signal. Sir, this is complex exponential. Yes, we can call it as complex exponential, but the more appropriate word is complex sinusoidal signal. There is nothing wrong in calling it as complex exponential, but it is complex sinusoidal because if you expand this, it becomes cos omega t naught minus j sin omega t naught. Two sinusoidal signals in the real part and imaginary part. That's why we call it as complex sinusoidal signal. I'll just to avoid confusion, I'll tell you e power minus 3t or e power minus 4t plus 4t, something like this, with u of t or without u of t. We call them as real exponential signals because all the values taken by this are real values, real exponential signals. And if you take something like this j4t minus j3t, something like this, the j factor means, so if you can write e power j4t as cos 4t plus j sin 4t. So it looks like cos 4t plus j sin 4t. So sinusoidal in the real part and in the imaginary part. That's why we call them as complex sinusoidal signals. Complex sinusoidal signals. Similarly, e power 2 plus 3j into t, something like this. In the power, apart from the variable, whatever constant we have, if that constant is real, then it will be real exponential. If that constant is purely imaginary, then it becomes a complex sinusoidal signal. If that constant becomes complex with their both real and imaginary parts, we call it as complex exponential signal. Okay, right, very simple. So if you do shifting in one time domain, what happens in the other domain? Same Fourier transform, just copy. It will be multiplied with complex sinusoidal signal. Complex sinusoidal signal, where in that complex sinusoidal signal, e power j, since it is complex sinusoidal, j will be there. What is the variable in frequency domain? Omega is the variable. And what is multiplied to that in the power? What should be there? Whatever is the shifting part, how much amount you are shifting, that is copied there. Whatever is the shifting, whatever is the amount of shifting, you just copy it there. If it is minus here, it will be minus here. Very simple, right? Very good. Same thing, I can just rewrite it. X of t plus t naught, if you do, if you shifted the signal towards left side, same basic, you are replacing, instead of minus t naught, you are having t naught. Instead of minus t naught, let us have it as plus t. So in time shifting property, same sign here and here. Okay. In frequency shifting property, it will be slightly different. We'll discuss that in the next slide. Okay, I hope this is clear. Right. So let us discuss frequency shifting property also, and then we'll move on to problems. Right. What is the frequency shifting property? They are saying that if x of t has a Fourier transform of x of omega, what it means is, if you know a signal and its Fourier transform, if you already know a signal and its Fourier transform, then with the help of property we can find the Fourier transform of many other signals. Okay, without knowing a Fourier transform of a particular signal, we can't find the Fourier transform of shifted versions or some other variants of it. First of all, we should know the Fourier transform of a particular signal, or we should know a Fourier transform pair. What I mean by Fourier transform pair, let's say del of t, Fourier transform is 1. You know the Fourier transform of del of t. Using time shifting property, you can find the Fourier transform of any shifted version of del of t. Okay, any shifted version of del of t. Right. So this is Fourier transform pair. So del of t Fourier transform is 1. 1 inverse Fourier transform is del of t. So these two things together we call it as Fourier transform pair. Only once you know a Fourier transform pair, then only we can apply all these properties. Without knowing any Fourier transform pair, we can't apply these properties. Okay, right. So what they are saying, then the inverse Fourier transform of, then the inverse Fourier transform of x of omega minus omega naught. Let me say this is capital X. Okay. Then the inverse Fourier transform of x of omega minus omega naught. See this one, shifting in frequency domain is happening. Shifting is happening in frequency domain. So we know Fourier transform satisfies duality property. So which means what happens in one way, same happens in the opposite way also. So earlier we have discussed shifting in time domain. If you do, what happens in frequency domain? It is the Fourier transform is getting multiplied with complex sinusoidal. Similar thing will happen here also. Shifting is happening in frequency domain. So what happens in time domain is multiplication with complex sinusoidal happens, e power j omega naught into t. The variable here is t. But earlier in this previous property, the sign was same, but here the sign will be exactly opposite. If it is minus here, it will be plus here. We can easily prove these properties. Take the Fourier transform formula and inverse Fourier transform formula. We can easily prove them. Okay. Right. Okay. So shifting in frequency domain, what is it doing to time domain? Multiplication with complex sinusoid. Okay. Right. So we have understood the properties. Now let us discuss the problems based on it. So first we will discuss problems based on time shifting property, and then with frequency shifting property, and then if possible I'll mix both the properties and I'll ask you questions. So let's do them. So let me ask you the first question. Find Fourier transform of the following signals. First question. So can you find the Fourier transform of this signal? What is the Fourier transform of this signal? Can anyone find it? I'll wait for a minute and then I'll explain what is the procedure to do it. First look at this signal. This is looking like some kind of shifted version of some signal, right? First find the Fourier transform of original signal x of t and then find the Fourier transform of shifted version of it. Okay. So you can observe that okay, some kind of time shifting is happening, which means you'll get the idea that okay, I have to use time shifting property. Correct? So if there is any slight confusion, just write the time shifting property once, then it will be clear. X of t Fourier transform is x of omega, then x of t minus t naught Fourier transform is x of omega into e power minus j omega t naught, right? Keeping this in mind, so first of all, you should know one Fourier transform, which is first of all you should know the Fourier transform of one signal, which is this is the signal that we want to find Fourier transform. Without shifting, let us write it. Without shifting. So instead of t minus 3, just have it as only t, which means without shifting, you can imagine it as this as x of t. If you imagine this as x of t, then this is looking like x of t minus 3. Correct? This is looking like x of t minus 3. Replace t with t minus 3. Okay, so whatever signal they ask us to find Fourier transform, don't try to find the Fourier transform that signal directly. First of all, look at that signal without that shifting, okay, or without that extra operation that is being happening. You know this signal very well, we know this signal very well, we are comfortable with this signal. Look for that signal, which is an easy signal to find Fourier transform. Inside whatever signal they have given, inside that signal, removing all the operations that they are doing, shifting, differentiation, all the other whatever operations you can, without those operations, if you can look at that signal, then the problem becomes easy, right? So I can see only one operation happening here, that is time shifting. I have removed the time shifting operation, then the signal is going to look like this. So if we know the Fourier transform of this one, we can find the Fourier transform of this one using time shifting property. So what is the Fourier transform of this signal? It's a very simple Fourier transform. E power minus at into u of t. It's a Fourier transform which we all remember. It is 1 by a plus j omega, and this happens only if a is positive. If a is negative, Fourier transform does not exist. Okay, right. So from that, it is 1 by 2 plus j omega. Since a is a positive value, yes, Fourier transform exists. Fourier transform exists only if it is a decreasing exponential. So this is an absolutely integrable signal. So Fourier transform exists for us. So if a is negative here, then this is an exponentially increasing signal. It becomes a neither energy nor power signal, and hence Fourier transform will not exist if a is negative. Fine. So we know the Fourier transform of this. By using time shifting property, we can find the Fourier transform of this one, which is, we know the Fourier transform of this. If you shift it, what happens to the Fourier transform? Same Fourier transform, just copy it. Same Fourier transform, just copy it. Multiply with complex sinusoidal signal. J omega. What is T naught? T naught is minus 3. So it is, if there is a minus sign here, same minus sign. That's it. We got the answer. The answer is 1 by 2 plus j omega into e power j omega 3. That is the answer. Let me ask you one more question. Second question. So how about the Fourier transform of this one? This is the question. So there is some kind of time shifting happening here also. Without that shifting, write the signal. Then with shifting, we can find the Fourier transform. Anyone can answer it? All Fourier transform problems, we have to do it in a certain manner. First, you should know the property clearly. You write the property clearly. Then try to look at the signal as some basic signal, and on that basic signal, you're doing some operation. Then you get this signal. You have to look at it in that way. Whatever signal they give you, you can just look at it, that signal, without any operations that are happening, without shifting, without differentiation, without integration. If you can look at them as very basic signals without the operations, then you can find the Fourier transform of that basic signal easily. And then by applying property, you can find the Fourier transform of given signal. Okay, right? So here some kind of shifting is happening. T plus 4. You can also look at it here as minus. If you take common, you can also look at it as t plus 4 instead of t plus 4. So let us look at it as x of t plus 4, because there is t plus 4. Let me write as x of t plus 4. Then it is into u of minus of t plus 4. See this one? Then replace t plus 4 with t. Then what it will look like? It looks like e power 3t into u of minus t. So if you can find the Fourier transform of this one, which is easy, then you can also find the Fourier transform of this one using time shifting property. So what is the Fourier transform for this? Fourier transform for this is, I'll just recollect one formula using time reversal property. Using time reversal property, if you replace t with minus t, then in the frequency domain, replace omega with minus omega. Replace omega with minus omega. where a is positive. Same Fourier transform, same whatever we have remembered here, you can apply the same transform with the help of time reversal property. You can get this transform. Replace t with minus t in this, you get this. Okay. You don't need to remember many Fourier transform formulas. Only few, 4 or 5 Fourier transform formulas. That is more than sufficient. You can solve all the questions with the help of properties only. Right. So this is looking in this format. So what is the Fourier transform for this one? It is 1 by a minus j omega. In place of here, we are having 3. It is 1 by 3 minus j omega. Okay. Now let us look at this one. Now this is looking. We know the Fourier transform of x of t. What is the Fourier transform of x of t plus 4? Same Fourier transform copied. Same Fourier transform copied. It is multiplied with complex sinusoidal signal. 1 by 3 minus j omega multiplied with e power j, variable is omega. What is the shifting part? It is plus 4. E power j 4 omega. Plus sign here, same sign here. In time shift, when you are using time shifting property, same sign. Whatever is the sign in time domain, same sign you can see in the frequency domain. In frequency shifting properties, it is just opposite. Okay, I hope it is clear till this point. Fine, I'm moving on to the next question. So let us do questions based on frequency shifting property. Okay, I'll give you one more question based on time shifting itself. E power how about this one? Understand carefully. Try this one out. Same t plus 4 you are not seeing in both places. When you are not seeing, there is no direct formula to find it. There is no direct property to find it. You have to express it in the form of a shifted version of the signal. So what we have to do is adjust it. Adjust it in such a manner that you can get it into the required format, the format that you are comfortable with. Okay. Or else, what is the basic signal inside this one? The signal that we are comfortable with finding Fourier transform. E power minus 60 into u of t without any shifting. Yes, we know it very easily. And that is 1 by a plus j omega, which is 1 by 6 plus j omega. That is a Fourier transform. Now, we don't know any property where only t is replaced with t plus 4 only in this part. We don't know such kind of property, right? So what we do is, if this is x of t, let us find, since we are seeing t plus 4 in one place, x of t plus 4 is e power minus 6 into t plus 4 into u of t plus 4. See this one? So what is the Fourier transform of this one? We can find the Fourier transform of this one easily. Okay, but we don't want the Fourier transform of this. We want Fourier transform of this one. Okay, let's find this one. Then we can adjust things. Right? What is the Fourier transform of this one? X of t Fourier transform, we know x of t plus Fourier transform is same Fourier transform copied. Shifting in time domain, what happens in frequency domain? Multiplication with complex sinusoidal. E power j, omega is the variable. What is the shifting factor? Plus 4. This j 4 omega. Plus sign here, plus sign here. Yes, we got some answer. Right. Now let us do some adjustment here. So shall we write this as e power minus 60 into e power 6 4s are 24 minus 24 into u of t plus 4 Fourier transform is e power j 4 omega or j omega 4 divided by 6 plus j omega. See this one? We want only e power minus 60 into u of t plus 4. So what we can do is, let us divide both sides. Let us divide both sides with e power minus 24. Let us divide both sides with e power minus 24. Can we do that? Yes. Linearity property of Fourier transform. Whatever constant you multiply in time domain, same constant we should be multiplied in frequency domain also. Then e power minus 24 gets cancelled here. So finally, e power minus 60 into u of t plus 4 into u of t plus 4 has a Fourier transform of e power j4 omega plus 24. See this one? E power minus 24 to the numerator, it becomes e power plus 24 divided by 6 plus j omega. Or if you want, in the options, if you don't find this, then you can rearrange it a little bit. 4, if you can take common, it becomes j omega plus 6, or 6 plus j omega. Whatever you're seeing in the power, same thing in the denominator also, right? So sometimes when you don't find what you got in the options, it means that you have to rearrange your answer a little bit. Make some small changes to your answer, then you'll get an answer which matches with the options, provided you have not done any calculation mistakes. Okay, right. One more question I'll give you. E power minus 6 into t plus 4 into u of t. How about the Fourier transform for this one? Come on, make it fast. Should you do it in the same manner? Observe carefully and do it. See, only one place there is t plus 4. Then this t plus 4, u of t plus 4, there is no way you can make it u of t. Do any adjustment, you can't make it u of t, correct? Because this is a parameter which is inside the function. So we can't modify that. Whereas this we can modify. See this one? E power minus 60 into e power minus 24 into u of t. We can do this. E power minus 24 aside, e power minus 60 into u of t. This is what they're asking to find the Fourier transform of, correct? So we know the Fourier transform of e power minus 60 into u of t. What is that? It is 1 by 6 plus j omega. Now if you multiply the constant in time domain, same constant is multiplied in frequency domain also. That's it. This is an easy question. Here, don't try to adjust here. It's not possible to adjust. U of t, you can't make it u of t plus 4. By doing anything, you can't make it u of t plus 4. Right? So when there is shifting part only happening in only one of the places, if it is happening in inside u function, inside step function, then you have to adjust the new power part. Whereas if it is there only in the power, it is possible to adjust. It is possible to, whatever is inside the step function, that is not possible to adjust. But this one we can put it outside as a constant. Okay, this is a known function for which we can find Fourier transform. And if you know the Fourier transform of any signal, then we can find the Fourier transform of that signal multiplied with any constant using linearity property. Okay, I hope it is clear till this point. Fine. So let's move on to the next one. Let's see some examples on frequency shifting property. Find inverse Fourier transform of how about this one? Here also, look at this format. Exact format, we don't have anything in mind, but something close to that. Whatever Fourier transform we have seen, something close to this. Recollect that and first write it. What is the Fourier transform formula, that Fourier transform that you have remembered, which is close to this? In the previous page itself, we have seen it is 1 by a plus j omega, correct? So it is something like 1 by 3 plus j omega. So what is inverse Fourier transform for this one? E power minus 3t into u of t, correct? E power minus 3t into u of t has a Fourier transform 1 by 3 plus j omega, but they are not talking about that, some other variant of it. So if you look at this as x of omega, then you can look at this as x of omega minus 3, correct? Replace omega with omega minus 3, you'll get the required function. Since you know the inverse Fourier transform of the basic function, basic signal, Then you can find the inverse Fourier transform of a modified version. This modified version is nothing but frequency shifted version. By using frequency shifting property, you can find the inverse Fourier transform of this also. But first of all, you should know the inverse Fourier transform, some basic version inside that signal. Okay, right. So what is it? So if you don't remember, just write the frequency shifting property first. X of t Fourier transform is x of omega. Then if x of t is multiplied with e power j omega naught into t, then it will be x of omega minus omega naught is the Fourier transform of this. Same thing. Right. So x of omega minus omega naught inverse Fourier transform is same signal time domain copied, multiplied with e power j, t is the variable, omega naught is the shifting factor. If there is minus sign here, it will be a plus sign here. So same Fourier transform copied, e power minus 3t into u of t copied as it is, multiplied with e power j, t is the variable, and what is the frequency shifting part? 3, minus sign here, it is opposite sign. When we are using frequency shifting property, the sign is opposite. That's it. We got the answer. The inverse Fourier transform of this function is e power minus 3t into u of t into e power j3. If you don't find this in the options, you can just rearrange it a little bit. E power 3, you can take it common, minus 3 plus, sorry, in the options, if you don't find this, you have to rearrange it. E power minus 1 plus j into 3, minus 1 here plus j here, common 3 into u of. Okay, fine. Any other complicated Fourier transform also, first look at the basic version of it, like this. In this, I'm looking at the basic version of this Fourier transform and the modified version of it. Right. I'll ask you one more question. I'm asking you the Fourier transform of u of t into e power j3t. So what is the basic function inside this? We know u of t very well. What I mean by basic function is the function for which we know the Fourier or inverse Fourier transform. The function for which we know Fourier transform or inverse Fourier transform. Look for that function inside the complicated function. Pick that function, write the Fourier transform of it. The Fourier transform of u of t is pi into del of omega plus 1 by j omega. Okay. Now they're asking us to find the Fourier transform of u of t into e power j3t. Look at this one. U of t is like x of t here. In place of omega naught, we are having 3 here. So the Fourier transform will be, if this is x of omega, what we are going to have here is x of omega minus 3. See this one? In place of omega naught, we are having 3. It is x of omega minus 3. So in this function, wherever omega is there, replace it with 3. So it is pi into del of omega minus 3 plus 1 divided by j into omega minus 3. Okay, that's it. Got the answer. I hope it is clear till this point. So let's do one more question. Seventh question. So this is what I'm asking you. So what is the look at the basic version of it. It is looking like, see this one, this is 7 square. It is looking like 2 into 7 divided by 7 square plus, instead of omega minus 4 whole square, let me write as omega square. So that is the basic function that we might have remembered. So let me write that function. E power minus a mod t, that is a function whose Fourier transform is 2a by a square plus omega square. So this is one Fourier transform that we have to remember. Out of 4 or 5 Fourier transform that we have to remember, this is one of them. Very important. So e power minus a mod t Fourier transform is 2a by a square plus omega square. So look at this function. What is the inverse Fourier transform of this function? In place of a we are having 7 here. So it is e power minus 7 mod t. Okay. Now what are we seeing here? What we are seeing here is, we don't want the inverse Fourier transform of this one, but a modified version of this one. So 2 into 7 divided by 7 square plus omega minus 4 whole square. So if this is x of omega, this is like x of omega minus 4, omega replaced with omega minus 4. So x of omega minus 4 inverse Fourier transform is same time function copied, multiplied with e power j, variable is t, and shifting part is minus 4, so it will be plus 4 here, j4t. So the answer for this is e power minus 7 mod t into e power j4t. Okay, that is the answer. Okay, very good. Right. So let's take some other examples. When I say other examples, I want to mix these two properties together. Find Fourier transform of u of t minus 6 into e power j 7t. Talking about this. What is the basic function inside this that we are comfortable with? U of t is the basic function. Apart from that, what else operations they are doing? Shifting and multiplication with some complex sinusoid, right? So there are two operations that are happening on this. So we can deal with those both operations one by one. So let's do it. U of t. Let's find the Fourier transform of this one. We know the Fourier transform, that's a formula that we have to remember. U of t Fourier transform is very important formula that we have to remember. So it is pi into del of omega plus 1 by j omega. Next, u of t minus 6, we can find it now. Using time shifting property, we can find it. It is same Fourier transform copied, multiplied with complex sinusoidal. Complex sinusoidal, which is e power minus sign here, same minus sign here, minus j, variable is 4, and shifting factor is 6, j6 omega. Next, for this function, we are multiplying with complex sinusoid. Okay. We are multiplying this with complex sinusoidal. When you multiply this with complex sinusoidal, what happens? If this is x of omega, then this becomes x of omega minus 7. If this is x of omega, then what we are going to have here is x of omega minus 7. Okay. Because you are multiplying with e power j70, what does that do to the Fourier transform? Shifting by 6 units towards right, 7 units towards right side. So wherever omega is there in the Fourier transform, same Fourier transform, replace omega with omega minus 7. Because of multiplication with this, shifting happens in frequency domain. Wherever you see omega, replace it with omega minus 7. So if you want, we can simplify this further. Pi into del function, if you multiply with this, what happens is, whatever is the neighboring function, you're going to substitute omega with the location of the impulse. Location of impulse is at omega equal to 7. Wherever omega is there, replace it with 7. Then it becomes 7 minus 7 is 0. So it is del of omega minus 7. And when you substitute omega with 7 here, it becomes 1. plus second part is e power j into 6 into omega minus 7 divided by j into omega minus 7. That is the answer. So I've simplified the first part. These two terms together, if you apply properties of impulse, you get this. Second term will become 1. I'm using the property of x of t into del of t minus t naught. What is the result? Well, the location of impulse is t naught, t equal to t naught. In the neighboring function, wherever t is there, replace it with t naught. This property I'm using. But the variable instead of t, variable is omega, but same property. This is the neighboring function. Instead of, in place of this function, we are having this function. The location is omega equal to 7. So wherever omega is there, replace it with 7. So first part will become this much. And second part I'm just copying as it is. Okay. Any doubts, any questions you have, you can ask me. Right. So if you have not subscribed to our channel, you can subscribe to our channel. And if you like the content that I'm sharing with you guys, you can like the video also. Right. So for the next 4 days, I'll be discussing some other properties, some other concepts on Fourier transform. So if you are interested to learn Fourier transforms, you can watch my lectures every day on YouTube at 8 o'clock on our channel. So I've already taken 2 classes yesterday and day before yesterday. This is the third session, and I'll be taking 4 more sessions. So if you wish to learn, you can join same time tomorrow, day after tomorrow for the next 4 days. Right. So I'll give you some homework questions as well. I'll give you one homework question. Try this one. This will be an interesting question. Okay. Fine. So these are the homework questions. You can try them. So if you're able to answer them, you can post it in the comment section. So I'll look at the comments and see if anybody has answered the questions. And tomorrow, at the starting of the session, I'll tell you the answers for these questions. Okay. Fine, guys. I hope the session is useful. So don't forget to like the session. So if you like the content, that's it from my side for today. So tomorrow we'll be talking about some other concept on Fourier transform. Same time, 8 o'clock. Fine then. Take care. Good night.